So I did problem number 1. I started by drawing a picture of the golf ball and how it would go in a parabola, and labeling my dy max and my dx max, and labeling the variables I was given. And then I drew it in a triangle to show that the angle was 34 degrees and the velocity that was given was 50 meters per second. And I drew it in the triangle with the Vx and the Vy. And then to find these variables, I set up trig equations. So to find Vx, I did cos 34 equals Vx over 50 meters per second. And I found that the Vx was 41.45 meters per second. And then to find Vy, I did sine 34 equals Vy over 50 meters per second. And then multiplied 50 on each side, and then on my calculator found that Vy was 27.96 meters per second. And then I set up my two charts because I know that it occurs at different times. So I first did mine at Ty max, set up my x and y with the Vi, Vf, At, and delta D. I plugged in my initial velocities that I found in the first part, and I know that my Vf was 0 because at y max it's 0, and then I filled in the 0 meters per second squared and then negative 9.8 meters per second squared because those are always given. And then I set up my equation using the equation Vs squared equals Vi squared plus 2a delta D, plugged in my variables to find that delta dy was 39.89 meters. That was the answer to part A. And then to find the answer for part B, I set up my other chart with at 2x max and setting up my x and y and the Vi, Vf, At, delta D. I once again plugged in my variables from before with the 41.45 and the 27.96 velocities. And then I again filled in my accelerations so that I always know that x is 0 and that y is negative 9.8 meters per second. I know that my delta D is 0 because when finding this it's always 0. The y factor is always 0. And since the acceleration is 0, I knew that my final was 41.45. I set up to find my time because I have to start with the y side in order to be able to get the delta D and x. So I set up my equation with delta D equals Vi times t plus 1/2 a times t squared. I plugged in my variables and got 27.96 times t plus 1/2 negative 9.8 t squared. I then multiplied 1/2 negative 9.8 to get negative 4.9. I added 4.9 t squared to the other side, divided by t, and then divided by 4.9 to get t equals 5.71 seconds. So I plugged that back in, and I know that it equals these two equal each other, so I could just take this and put it to this side. So then to find my delta D on the x side, I set up my equation as delta D equals VIT plus 1/2 AT squared, and since A is 0, I could just cross this whole section out because it cancels. Then I just did 41.45 times 5.71 to get my answer of 236.5, which I didn't write in there, but I will write it in now. So my delta D, if I have a pen that works, delta D equals 236.5 meters. And that's how I solve my problem.